All right, so today we are starting our lesson on SohCahToa. What is SohCahToa? It is trigonometry. So what is solving a triangle? Solving a triangle is solving all the sides and all the angles of a triangle, okay? If you think about it, if you know two sides and the angle between those two sides, there's only one way to draw the rest of the triangle, right? Like if I know this is, I don't know, 17 degrees, and I know this is 10 and this is 7, do you guys agree that there is only one way to draw this in both length and angle? Okay, this idea that you can know like something about a triangle and figure out the rest is the whole premise of this entire unit. The thing is, you have to rely on your scientific calculator to know these ratios. Okay, so every lesson, you need to bring a scientific calculator, okay, because your calculator has this information stored. Now, just looking ahead, our first few lessons will be on right triangles, and our last few lessons will be on non-right triangles. So for the next like 2 or 3 lessons, just remember that one of the angles will always be 90 degrees. So let's go back in time and think about similar figures, okay? What do we know about similarity? Well, if I asked you to use similarity to solve for E in this triangle, what would you do? Yes? So first thing you would probably do is give me a similarity statement, right? ABC is similar to triangle, and remember that this goes by angle, A, B, C. So which angle is equal to A? Yep, D, and then E, F. So it's alphabetical in this case, but it doesn't have to be. Okay, so what that means, based on what we know, is that AB over DE equals BC over EF equals AC over DF. Do you guys remember this? Okay, so we can use proportions. And how did we know these were similar, by the way? We had 3 ways. Yep. Angle, similarity, right? Okay, good. So if I want to solve for E, how do I do that? Yes?
Because 12 divided by 3 is 4, so that equals...
Okay, let's not do it like that. I really don't like solving for the scaling factor first and then applying it. We're going to use the equation here. So we're going to say 12 over 3 equals E over 4, because what you just told me is a calculation, Roland. It's not an equation. Do you see how this is an equation? It has a left-hand side, a right-hand side, an equal sign, and a variable. Okay, so then we say 3E equals 48 and E equals 16. Now here is the punchline of this question, okay, and of the whole unit in similarity. Every single triangle that has 36.9 here and 90 here is similar to any other triangle in the universe that has 36.9 here and 90 here, right? So you can scale it up and down, they will be similar. Now, what that means is that we can apply something else when we look at a triangle like this. We can use the backwards logic now. So instead of talking about angles, okay, what can I talk about instead? Yes? The side lengths, and in particular, not just the side lengths themselves, but the side lengths in relation to each other, right? So if I look at 9 and 12, and I ask you, what is the angle N? What is the one and only answer you can give me? Yes? It is 36.9 degrees. And that's because 12 over 9, which is N over O, NO over MO, no mo, is equal to AC over BC. Okay, and just like what I set up here with this this triangle here, I don't necessarily need to know the hypotenuse MN. There's only one answer there because I know this is 90 and I know this is 9 and this is 12. So similarity is linked into trigonometry in this way. And the thing is, I don't expect you to know 36.9. You know it because I just showed it to you up here, but I gave you 36.9. What you're going to do is rely on your calculator to give you 36.9. So everything you do from now on is going to rely on your calculator. So let's get out our calculators, please. And can you please evaluate 36.9 degrees? 0. Keep going.
0.8.
Yeah. Okay. So that is very close to 0.75. Okay, and that's because the 36.9 is rounded. Did anybody get anything else? Yes. What did you get? Okay. Hang on. What did you get? Tell me what you got. That's not my question, Elijah. What did you get? 0.27. Keep going.
-1.27.
I can't. You trailed off after 27.
81.04.
Okay. So I can tell right now that Elijah's calculator is in the wrong mode. Okay, because he got the wrong answer. Okay, so this means he's probably in radians mode. Okay, and we don't want this, okay, because we should be, if I'm giving you 36.9 degrees, you should be in degrees mode. Okay, so let's all look at our calculators, put them in degrees mode now. Okay, make sure that any calculation you do is in degrees mode. Okay?
How can I change my
That's on you. Okay, we'll talk after. So you need to know your calculator, okay, and we can talk offline, okay? All right, so I asked you to use tan, okay, but there are actually 3 buttons on your calculator responsible for trigonometry. Does anyone know what they are? I mean, it's the title of this unit. Okay, so the button is SIN, COS, and TAN. Okay, you'll see these buttons on your calculator, but let's pronounce them properly. Okay, this is sine, cosine, and tangent. Okay, so when I say it in short form, it's not sin, cos, and tan. It's sine, cos, and tan. Okay, so make sure you're saying it that way. Okay, so what we're going to do now is let's change the angle. Let's do tan 31 degrees. It's very easy. Just hit mode. Just hit mode and go to degrees, and you're done. Okay, clear that. Okay, so now can somebody please type in tan 31 degrees and tell me what you get? Okay, so, all right. What we're going to do is look at, actually, sorry, I missed something here. I'm sorry, I missed something here. Let's go back one page. Okay, so what this is saying, 36.9 degrees, and let's look at N, O, M again, 9 and 12. And, I mean, some of you know this already, but how do you think this number here relates to this triangle here with the numbers 9 and 12? How does 0.750821 relate to 9 and 12? Josh? Is what? Okay. So what we'll notice is the tan button on your calculator helps find the angle with relation to 2 sides of a triangle, and those 2 sides are always the same. Okay, so again, I'm going to repeat that. Tan 36.9 gives me a ratio of two sides of this triangle. And those two sides are always the same two sides. Does anyone know what they are, guys who have seen this before? Can you put this together for me? It's opposite over adjacent, okay? So the tan ratio, tan 36.9, is the ratio of the opposite side to the adjacent side, okay? And that's actually the definition of tangent. So I wanted to show you an example before we actually get into it, okay? So for example, now, if I take tan 31 degrees, we have to think of 0.6008 as equal to the opposite over adjacent sides in a triangle. Yes. 4. Okay, so before we actually answer this question, I want us to label in these triangles. Okay? So let's do this first and then we'll backtrack and finish this question. So I don't have it in here, but these two angles are both 90 degrees. Okay? And what I want to do is write down, I want to label this triangle with reference to an angle. Okay? So what we're going to do is we're going to call this angle theta and this angle alpha. Why theta and alpha? It is just convention. Okay. And so anytime you label a triangle, the first thing you need to do is acknowledge that you're labeling it with reference to a specific angle, okay? So what I like to call that is an angle of consideration or a perspective angle. So in this case, I'm going to call this my angle of consideration, okay? And in every right triangle, regardless actually of the angle of consideration, every right triangle has a hypotenuse. We agree? We know Pythagorean theorem. Okay, so on this triangle, where is the hypotenuse? Andreas? It's always the longer side. It's always opposite the 90-degree angle. Okay? Now, here is my angle of consideration, and now I have two things I need to label. I need to label the opposite side and the adjacent side. Okay, and it's always going to be with respect to our angle of consideration. So where would the opposite side go? Yes? Nope. It'll be all the way opposite of that angle. So the side that is spanned opposite of my angle of consideration is labeled the opposite side. The hypotenuse is always opposite the 90-degree angle. What does the word adjacent mean? Yeah, beside. And we'll notice that there are actually two sides adjacent this angle. There's this side and this side, right? But one of them's already labeled. It's already the hypotenuse, okay? So we're going to erase that, and we're going to call this side the adjacent side. Okay, so we're going to do this again. I'm going to call this alpha and this theta, but we're going to change our angle of consideration to this one, okay? Now, first things first, where's the hypotenuse of this second triangle? It's always opposite the right angle. Where is the opposite side in this scenario? Yep, it's the bottom, okay? And where's the adjacent side in this scenario? Yes, okay. So let's go back to this question. And what I'm going to do is I'm going to draw a right triangle, okay? Okay, and I want to create a triangle that represents tan 31 degrees equals 0.6008. So I want to make up a triangle. How do you think I can create a triangle that meets this criteria? Jed, what do you think? Pardon? Let's not, give me the triangle. Label this triangle so that it mostly fits this ratio. That's not what I mean. Give me some numbers, Andreas. We could put 31 degrees here, sure. And then? So I need opposite over adjacent. Yep, Josh, what do you think? Yeah, we don't need that. Yep.
For the adjacent is equal to 5,
Sure.
and then the opposite would be equal to 3.0.
Okay. I think this is an example of a triangle that represents tan 31 equals 0.6008. Uh-oh. Okay. Because my opposite to adjacent ratio is about 0.6. Let's do another one. Andreas, is that a question?
Yeah, how do we figure out 3 and 5? Just like until you
We're just making it up.
Oh, okay.
We just know that the opposite over adjacent has to equal 0.6-ish. I'm going to ask Josh to give me an example. I've even drawn it bigger. No, you don't need a calculator. You need to understand what the tan ratio is.
Opposite over adjacent.
That's right. And if opposite over adjacent needs to be 0.6, what numbers can I put in there that make it work?
Like 6 and 10.
Okay, like those numbers. Where does it go?
6 goes on the opposite side.
Opposite of what, though? Jeez, we don't have anything labeled.
Okay, so
Where's my angle of consideration?
the one on the left.
Okay, so what am I going to write there?
31
31. Okay, so actually, guys kind of skip over this part, but in a lot of ways, this is the most important thing to label, right? Because it's not opposite over adjacent of anything. It's opposite over adjacent up from that angle, right? Okay, so where am I going to put the 6 and the 10?
the 6 opposite of the 31.
Okay, so I like to go over this part of trigonometry just to remind you that trig just represents the ratio of sides from a certain angle, okay? So let's talk about the number of ways we can do this, okay? So what are all the possible ratios that can be made? So let's say this, again, is my angle of consideration. Help me label opposite, adjacent, and hypotenuse. Where does it go? Aaron? Mm-hmm. Yep. Yep. Okay, so we have 3 sides of a triangle. How many different formations of ratios of sides can I make? What do you think, Jed? There are actually 6, but 3 is, yes. Okay, so give me one of them, Elijah. Opposite over adjacent is one of them. Okay, give me another example, Remy. Opposite over hypotenuse is another one. Give me another one, Evan. Adjacent over hypotenuse. Give me another one, Roland. Hypotenuse over adjacent. Give me another one, Andreas.
Could do hypotenuse over
Opposite, and then, yep.
It would be adjacent over opposite.
Okay, so guess what? In a triangle, there are 6 different ratios you can be asked for. We do 3 of them in this course, and then next year you do all 6 of them. Okay? So this year we do SohCahToa. Next year you do secant, cosecant, and cotangent. Okay, so don't worry about those now, but essentially they're just flipped. So this one has a name. This one we already know, it's tan. Okay. Does anybody who may have seen this before recognize the other 2 that I'm about to talk about? Yep,
The opposite over hypotenuse is sine.
you got it.
And adjacent over hypotenuse is cosine.
Okay. So it just so happens that these are the primary trig ratios. The other ones are called reciprocal trig ratios. You will learn them next year, okay? So there's a mnemonic, SohCahToa or SohCahToa, however you want to say it, to help us memorize these three trig ratios. What's up?
Are the other ones secondary?
They're called reciprocal trig. You don't need to know that. I didn't write it down. Okay, so SohCahToa. Sine theta. Okay, always theta. So some guys, when they're new to trig, they just don't write anything there. They just say sine equals. But remember, you need to tell me what the angle of consideration is. Okay, is the opposite, hang on, I'm going to do this in capital letters, opposite over hypotenuse. Okay, cos theta is adjacent over hypotenuse, and tan theta is opposite over adjacent. There you go. You've just learned right angle trig. Now, there are two concepts we need to know using this. And you need, remember guys, you need your calculator. There are only a handful of triangles you can figure out without a calculator. So let's do it. So part one is the easy part. It's finding side lengths. All right, so here we go. How do we do this? Well, first things first, we're going to circle our angle of consideration, which here is 26. It doesn't have to be 26. It can be the other angle, but I'm choosing 26. Okay, now based on this, I'm going to label my triangle. So I know the hypotenuse is here. Help me label opposite and adjacent sides, Elijah. Yep, you got it. Okay. Now here's the thing. I have a known and an unknown side, and then I have a side with nothing on it, the hypotenuse, right? So in this case, the hypotenuse doesn't really come into play. So I can see that I need the trig ratio that associates opposite and adjacent. So which one is that? Yes. It's not sine. Yes. So it's going to be tan theta is opposite over adjacent. We're going to use that one. Okay, so now I just fill in the numbers. Tan 26 degrees equals 15. Nope. Equals x over 15. Okay, and now this is where your calculator comes into play. Can everybody please get their calculator out? Tan 26, and here's the thing. Trig is all about approximations. So you have to keep 4 decimal places at all times until the final answer. So right now I would like everyone to get out their calculator and do tan 26 to 4 decimal places, please.
0.4877.
Okay, 0.4877 obviously times 15 equals x. Can you tell me what x is? To 4 decimal places. 3159, or what comes after the 9? So great lesson here, because I'm handing back your quizzes today and some of you guys don't know how to round. Okay, so if I'm asking you here to round to 4 decimal places, okay, is this it? Is this how I round to 4 decimal places? Is this how I round this to 4 decimal places? That's how I round this to 4 decimal places. Okay, the 59 turns into 60, not 6. Okay, so my final answer should be the missing side is nearest tenth of a meter. 7.3 meters. Okay. Can we do one more example? And then I want to give you like 5 minutes to go through a bunch yourself. Okay? So, SohCahToa, what am I doing for this one? I have 57 here. Opposite, adjacent, what do I do? Am I using sine, cos, or tan? We're using tan again. We'll just go right to the answer. Tan 57 is 14 over y. I'm going to write this as y equals 14 over tan 57. Let's put that right into our calculator to 4 decimal places, please. What do I get?
Nine
9.0157?
one seven.
0117.
0917.
Okay, so to the nearest tenth of a meter, okay, the missing value is 9.1 millimeters. Okay, can I give you guys a little bit of time now to do example 3, and then 4 has all these answers? All right, so guys, part 2. So in all of these questions we just did, I was asking you to find a side length, but the other aspect of solving triangles is finding the angles, okay? So again, let's just remind ourselves how to label a triangle. Hypotenuse, opposite, adjacent. Okay, so what I want us to do is just explore 2 things for a second. Can everybody go in their calculator and tell me what tan 54.5 degrees equals? How many zeros? 1.19. Okay, so again, it's roughly 1.4. And now what we're going to do is evaluate in your calculator tan inverse of, guess what, 1.4. How do I do that? Well, if you look at your calculator right now, everybody's calculator is different, so this is why you need to bring your own calculator, use your own calculator, know it, okay? But on my calculator, my sine, cos, and tan buttons have sine inverse, cos inverse, so it looks like this, sine, cos, tan, sine, cos, tan. And then on top of it, it has sine inverse, cos inverse, and tan inverse. So for me, I press my shift key, okay, and then I press the sine button to get inverse sine. So can everybody locate that button on their own calculator and do tan inverse of 1.4 and give me the answer, please? What do you got?
54.4623.
Okay. All right. So here we go. We have this idea that tan 54.5 degrees equals 1.4, and tan inverse of 1.4 equals 55 degrees. What does that mean? What do you think the relationship is there? How are they connected? Yes. It's an inverse function. The same way, if I take 5 squared equals 25, and I take the square root of 25, it equals 5. Okay, this is not strictly speaking true because the square root of 5 is actually plus minus 5. But if we're taking the positive answers, these 2 items undo each other. Okay? So essentially what you can say to yourself is, okay, if I have 54.5 degrees, okay, and this is 14 and this is 10, what I could do is if I have like this angle here and I have 7 and 5, I can use my calculator to figure out the angle by working backwards. So I can say something like tan theta is 7 over 5, and then I can isolate theta by taking the inverse of both sides. Like this. Okay, so tan inverse sort of undoes tan. It's the opposite operation of tan, the same way as square root and a power of 2 are opposite operations. So let's use this to figure out some angles, okay? So in this case, I want to find A. So A is my angle of consideration. My opposite side is 8. My adjacent side is 10. So my first line, so guys here, I've already walked around and I'm seeing some bad habits right off the bat. You need to write down the trig ratio first. You don't go x equals right away. Your first line should always be something like this. Tan A equals 8 over 10. Okay, so you should have a trig ratio on one side and a fraction on the other side. Now what I'm going to do is recognize that A is tan inverse of 8 over 10. Can everyone please put this in your own calculator and see what you get? Do the work. Point what?
I got 38.659.
Yeah, I got 38.6.
I'm getting lots of 38s here. Okay, so what you guys might be doing is doing tan inverse 8 and dividing the result by 10. Okay, make sure that you're doing 8 divided by 10 in brackets. Okay, the correct answer is 38.6598.
I was on the wrong page.
And by the way, guys, you're in degrees, okay? Your answer is in degrees because guess what? Your calculator mode is in degrees. Okay, find F. Guys, can we find F by inspection?
Yes.
What is it? 45 degrees, 0.0 degrees to 1 decimal place. Okay, what about P? Let's look at P. Again, I think I've gotten all tans here. Tan P equals 14 over 11. P is tan inverse 14 over 11. P equals, try it guys, you guys do it. You can even do 14 divided by 11 first and then apply tan inverse to the result. I'm getting 51.8428 degrees. Okay, I'm going to stop recording and you guys